Now whether screen is visible, everyone? Hello? Whether screen is visible? So I think last time we have solved two problems based on the Bell-Coleman cycle. So for practicing purpose, we will take one more problem. Now shall we start? So third problem based on the Bell-Coleman cycle. Okay. We'll read the problem. Akash Walsange. Akash Walsange. Can you read the problem loudly?
Yes, sir.
Huh.
An air refrigerator works between the
Pressure limits of.
surrounding. Yes, surrounding.
Hello.
Ah, yes, sir.
What happened?
An air refrigerator works between the pressure limit of 1 bar and 5 bar. The temperature of the air entering the compressor and expansion cylinder are 10 degrees Celsius and 25 degrees Celsius respectively. The expansion and compression follow the law P raised to 1.3 is equal to constant. Find the following parameters. The theoretical COP of the refrigerating cycle. Second one, if the load on the refrigerating machine is 10 air, find the amount of air calculated per minute through the system, assuming that actual COP is 50% of the theoretical COP. Take CP is equal to 1.005 kilojoule per kg Kelvin and CV is equal to 0.71 kilojoule per kg Kelvin.
Okay, thank you. So here, what they have given, there is one air refrigerator which is working between the pressure limit of 1 bar and 5 bar. So as
Yes,
they have
sir.
mentioned 1 bar and 5 bar. So 1 bar is nothing but the lower pressure which will be denoted by P1 is equal to P4 because we are knowing the PV diagram and CS diagram. So if you see the PV diagram, so in case of PV diagram, so 1 to 2 process is likewise, 2 to 3 process constant pressure, 3 to 4 and 4 to 1 process is likewise. So here whatever 4 to 1 process is there, this is called as a 4 to 1 process, this will be called as a constant pressure process, and this is called as a 2 to 3 process, this is again constant pressure process. So here P2 is equal to P3 and P1 is equal to P4, whereas lower pressure is nothing but P1 is equal to P4. So here if you see 1 bar is nothing but lower as compared to 5 bar. So 1 bar is corresponding to P1 and which is equal to P4. And whatever another value is there, that is nothing but 5 bar, that is corresponding to P2 is equal to P3. So now next point is the temperature of air entering the compressor and expansion cylinder are 10 degrees centigrade and 25 degrees centigrade respectively. As the word respectively is there, that's why here whatever 10 degree centigrade is there, that 10 degree centigrade is corresponding to 10 degree centigrade is corresponding to inlet of compressor, because here they have clearly mentioned that air entering the compressor and expansion device. So 10 degree centigrade is inlet of compressor. Inlet of compressor always we are indicating by temperature T1. So that is nothing but the temperature T1 which is equal to 10 degree centigrade. And another one, expansion cylinder. So inlet of expansion cylinder. So which is the expansion process? 3 to 4 is the expansion process. 1 to 2 is compression process. 2 to 3 is a constant pressure heat rejection process.
Yes.
3 to 4 is expansion process and 4 to 1 is again constant pressure heat absorption process. So inlet of expansion means they have mentioned the value of T3. So here whatever 25 degree centigrade is there, that is nothing but the value of T3. So here they have mentioned that expansion and compression. expansion and compression follows the law PV raised to 1.3 is equal to constant. That means both compression and expansion process follows the law PV raised to 1.3 is equal to constant. It will indicate that value of En is equal to 1.3. So here, if you draw the PV and TS diagram, so this will be your PV diagram. This will be your PV diagram. This will be your TS diagram for Bell-Coleman cycle. So here, as compression and expansion are following the law PV raised to 1.3 is equal to constant, that means they have given value of En as a 1.3. Value of En as a 1.3. So here, what we have to find out? We have to find out the value of theoretical COP of the refrigeration cycle. So first of all, we have to calculate the value of COP. So for calculation of value of COP, which formula we have to use? Formula number 1, 2, or 3? Can anybody tell me? For calculation of COP.
2.
For formula number 2 we have to use, because both the processes are polytropic processes. So first of all, we have to calculate the theoretical COP of the refrigeration cycle. Second, if you see, if the load on the refrigerating machine is 10 TR, load on a refrigerating machine is 10 TR, that means they have provided the value of amount of heat absorption or heat absorption capacity of that refrigerating machine. So load is nothing but amount of heat absorption, whose value is nothing but 10 TR, and the amount of air circulated per minute to the system, assuming that actual COP is 50% of the theoretical COP. So what exactly we have to find out from point number 2? Here we have to find out value of mass of air circulated. Mass of air circulated per minute. When, for which condition we have to calculate the mass of air circulated per minute? We have to calculate the value of MA for refrigerating machine capacity of 10 TR, and when actual COP is 50% of the theoretical COP. That means here, by using first equation or by using first point, we will get the theoretical COP. So after getting the theoretical COP, if we are going to consider the actual COP as a 50% of theoretical COP, then by considering the actual COP, we have to calculate the actual mass of the refrigerant passing through, actual amount of air circulated through the system per unit time. So here, for that purpose, we have to take the value of CP as a 1.005 and value of CV. Here they have specially mentioned the value of CP and CV for this problem. If you see the previous two problem, whether they have mentioned the value of CP and CV in the previous two problem, they might have mentioned the value of CP, but they haven't mentioned the value of CV. But here, as they have mentioned the value of CP and CV, so by using the value of CP and CV, you have to calculate the value of, by using the value of CP and CV, you have to calculate the value of R. So we are knowing that R is nothing but equal to, what is the formula for R? Can anybody tell me what is the formula for R? R is nothing but Cp minus Cv. R is nothing but Cp minus Cv. So here, whatever value of R we have to calculate, that value of R we have to calculate by considering the value of Cp and by considering the value of Cv. So here, as actual COP is 50% of theoretical COP and value of Cp and Cv are nothing but 1.005 and 0.71. Whether my voice is clear to everyone?
Yes, sir.
Whether PPTs are visible to everyone?
Sir.
Okay. So here, as Cp and Cv value they have mentioned, so based on Cp and Cv, we will calculate the value of R. Now, first of all, as we have to calculate the theoretical COP of the refrigerating cycle, so which formula we are going to use? That is nothing but formula number 2. Can anybody tell me what is the formula? COP is equal to, कोणता formula use करणार आहे आपण? Can anybody tell me what is the formula, or which formula we have to use? COP is equal to माहित आहे का कुणाला T1
T1 T4
T1 minus T4 divided by
N upon N minus 1
divided by N upon N minus 1 N upon N minus 1 into another
Yeah.
bracket
gamma
gamma minus 1 upon gamma minus 1 upon gamma into inside the bracket
T2 minus T3.
T2 minus T3. Here you have to only observe the TS diagram. By observing the TS diagram also you are able to find out this formula, because here amount of heat absorption will take place during the process 1 to 4 and amount of heat rejection process will take place during the process 2 to 3. So here, as we are knowing, the in general formula is nothing but QA, formula of COP. In general formula of COP is nothing but QA divided by QR minus QA. So here QA is taking place during the process. QA is taking place during the process 4 to 1. So we have to consider highest temperature minus lowest temperature. So T1 minus T4. Here QR minus QA. So here QR is taking place during the process 3 to or 2 to 3. So here we have to consider T2 minus T3. T2 minus T3 into another bracket. Into another bracket, what will be the value? Minus T1 minus T4. T1 minus T4. That formula you have to use. So this will be the formula. So here, if you see the given data, in the given data they have provided the value of T1 and T3. Whether they have provided the value of T2 and T4 in the given data, they haven't provided the value of T2 and T4, because here if you see, you are knowing the value of T1, you are knowing the value of T3, but if you see the formula of COP, you require all the temperature value. That is nothing but T1, T2, T3, T4. So value of T2 and value of T4 are unknown quantities. So how to calculate the value of T2 and T4? So for that purpose, we have to consider the process 1 to 2 and process 3 to 4. So as process 1 to 2, this process as process 1 to 2 is a polytropic process, because it is following the law PV raised to 1.3 is equal to constant. So for this process, I can use the formula. First of all, I will calculate the value of work done. Here by another way, we are calculating the value of COP. By both the way, you are able to calculate the value. That means here, if you use P2 by T1 is equal to P2 by P1 raised to gamma minus 1 upon gamma, that formula. And if you calculate the value of T2, then by using the process 3 to 4, here again, by using the process 3 to 4, again, if you are going to use the formula T3 by T4 is equal to P3 by P4 raised to gamma minus 1 upon gamma, then here you will get the value of T4. So by both the way, that means after getting the value of T2 and T4, if you use the formula number 2, you will get the value of COP, theoretical value of COP. And another way is nothing but by calculating the work done during the process 1 to 2, work done or work obtained during the process 3 to 4, and by calculating the value of QA. So by both the way, you are able to calculate the value of COP. So choice is yours, which method you have to follow. So here we are following the method, that is, first of all, we will individually calculate the value of amount of work done during the process 1 to 2, that means during the compression. After that, we will calculate the work obtained during the process 3 to 4, that means first of all, we will calculate the value of W1 to 2, then we will calculate the value of W3 to 4. So as value of W1 to 2 is greater than value of W3 to 4, so we will calculate the value of net work, W net, that is nothing but equal to W1 to 2 minus W2 to 3, W3 to 4, W3 to 4. So here I will get the value of net work done. So after getting the value of net work done, I will calculate the value of amount of heat absorbed per kg of the air. So for that purpose, I will use the formula Cp into here. Heat absorption process is taking place during the process 4 to 1. So here I will use the formula Cp into T1 minus T4. T1 minus T4. So here I will get the value of QA also. So after getting the value of W net and after getting the value of QA, I will get the value of COP. I will get the value of COP. Formula of COP will be W net divided by QA. So I am going to use this method. Are you getting? Yes or no? समजतंय कोणती मेथड वापरणार आहे आपण ते? हॅलो, काहीतरी सांगा, समजलंय किंवा नाही समजलंय? नसेल तर अजून एकदा एक्सप्लेन करतो.
Sir, repeat once again.
Repeat once again. Okay. मराठीतून एक्सप्लेन करतो पर्पजफुली, लक्ष द्या 2 मिनिटं. त्या ठिकाणी आपल्याला सीओपी कॅल्क्युलेट करायचं आहे. काय कॅल्क्युलेट करायचं आहे? थेरॉटिकल सीओपी. आता थेरॉटिकल सीओपी कॅल्क्युलेट करायच्या 2 मेथड आहेत. पहिली मेथड कोणती आहे? आपण फॉर्म्युला कोणता वापरणार आहे? त्या ठिकाणी T1 मायनस T4 एक तर हा तर फॉर्म्युला वापरणार आहे T1 मायनस T4 डिवायडेड बाय हा n/n-1 इंटू गॅमा -1 इंटू परत ब्रॅकेटमध्ये T2 मायनस T3 मायनस T1 मायनस T4. म्हणजे ह्या ठिकाणी हा फॉर्म्युला जर यूज करायचा म्हटलं तर तुम्हाला n ची व्हॅल्यू माहित आहे, गॅमाची व्हॅल्यू माहित आहे, बरोबर? त्या ठिकाणी काय येईल? T2 येईल, T3 येईल, T1 येईल आणि T4 येईल. So if you want to use this formula, so here you are knowing the value of n because value of n is nothing but 1.3. You are knowing the value of gamma but 1.4. You are knowing the value of T1. You are knowing the value of T3. Again, value of T1 is known to you. So what is the unknown quantity for using this formula? Value of T4 and value of T2. बरोबर आहे? हे दोनच व्हॅल्यू अननोन आहेत ना? येस और नो?
Yes, sir.
आता त्या 2 व्हॅल्यू जर कॅल्क्युलेट करायचे असतील तर T2 आणि T4 कसा कॅल्क्युलेट करणार आहे मी? तर T2 कॅल्क्युलेट करण्यासाठी मी काय करणार आहे? प्रोसेस 1 to 2 बघणार आहे. प्रोसेस 1 to 2 कशी आपली पॉलिट्रॉपिक प्रोसेस आहे. प्रोसेस 1 to 2 कसे पॉलिट्रॉपिक प्रोसेस आहे आणि त्या पॉलिट्रॉपिक प्रोसेससाठी आपल्याला टेम्परेचरचं प्रेशरमध्ये कन्वर्जन करायचं माहिती. व्हॉट इज द फॉर्म्युला फॉर पॉलिट्रॉपिक प्रोसेस? T2 by T1 is equal to what is the value? T2 by P1 raised to n-1 upon n n-1 upon n. So here if you see this formula, here you are knowing the value of T1, you are knowing the value of T2, you are knowing the value of T1, you are knowing the value of n. What is the unknown quantity? T2. So you are able to calculate the value of T2. You are able to calculate the value of T2. Similarly, here if you see another process, what is the next quantity that you want to calculate? You have to calculate again value of T4. So to calculate the value of T4, again you are knowing that 3 to 4 process is polytropic process. So for that 3 to 4 process also you can use the formula that is T3 divided by T4. T3 divided by T4 is equal to P3 divided by P4. P3 divided by P4 raised to again n-1 upon n. n-1 upon n. So here if you see, you are knowing the value of T3 because value of T3 is known to you. You are knowing the value of T3, you are knowing the value of T4, you are knowing the value of n. So unknown quantity, that is nothing but T4, you are able to calculate. So put this value of T4 in this formula, automatically you will get the value of COP. ही एक मेथड झाली. समजते ही मेथड?
Yes, sir.
बाकीच्यांना समजते का? Remaining student, whether you are getting? Yes or no?
Yes, sir.
Okay.
Yes, sir.
आता दुसरी मेथड कोणते? सेम सीओपी कॅल्क्युलेट करायसाठी दुसरी मेथड कोणते? या ठिकाणी मी काय कॅल्क्युलेट करू शकतोय? 1 to 2 प्रोसेस कसे पॉलिट्रॉपिक प्रोसेस आहे. म्हणजे पीव्ही डायग्रामचा यूज करून हा जर फॉर्म्युला यूज केला आपण n/n-1 into r into t2 minus t1. So here I will get the value of work done during the process 1 to 2. So here I am going to calculate value of W1 to 2 by using this formula. Similarly, by using the same formula, that means by changing the value of T2 and T1 by T3 and T4, I will get the value of W3 to 4. That means during the process 3 to 4, we are obtaining the work because this is the expansion process. So formula will be W3 to 4 is nothing but n/n-1 r into T3 minus T4. So here I will get the value of W3 to 4. W3 to 4. So after getting the value of W1 to 2 and W3 to 4, I will get the value of W net. I will get the value of W net. So after getting the value of W net, again I will calculate the value of QA. QA calculate करायचं असेल तर मला कोणती प्रोसेस बघायला लागणार आहे? TS डायग्राम मधली 4 to 1 प्रोसेस. So this is the amount of heat absorption process. So here QA I will get by using the formula Cp into delta T, that is nothing but T1 minus T4. T1 minus T4. Here in this formula is also I required to calculate the value of T2. I required to calculate the value of T4. So for that again I have to use the same method. So here I will get the value of QA. So after getting the value of QA, I will calculate the value of COP. Formula of COP will be equal to W net divided by QA divided by W net. QA divided by W net. So by using both the method, I am able to calculate the value of COP. Are you getting? Yes or no? Yes or no? But
Yes, sir.
easiest one is first one is the easier one. So you can use any one method. So here first of all I will calculate the value of W1 to 2, that is work done during the process 1 to 2 process. So formula will be this formula. In this formula value of T2 is unknown. Value of T2 is not known to us. So to calculate the value of T2, as we are knowing that T2 by T1 is equal to P2 by P1 raised to n-1 upon n. So here by putting this I will get the ratio for T2 by T1, and as I am knowing the value of T1, value of T1 is nothing but 283 Kelvin. So I will get the value of T2. So this is the value of T2. Put this value of T2 in this above equation, I will get the value of W1 to 2. So here if you see in this formula, again value of R is not known to us. Here we cannot take that value of R as a 0.287 or 287. Why we should not take? Because here they have separately provided the value of Cp and Cv. If they are going to provide the value of Cp as well as Cv, then that means we have to calculate the value of R. So value of R will be calculated by using the formula Cp minus Cv. So take the value of Cp, take the value of Cv. So this is the value of Cp, this is the value of Cv. Cp minus Cv is nothing but R. So here instead of 0.287, we have to take the value of R as a 0.295 kilojoule per kg Kelvin. So after putting the value of T2 and R in this equation, I will get the value of W1 to 2. I will get the value of W1 to 2. So here put the value of n as a 1.3 value of R as a 0.295. T2 is nothing but this value, and T1 already we are knowing. So after putting these values, I will get the value of work done during the process 1 to 2. Now what will be the unit? So here, as we are taking the value of R in terms of kilojoule per kg Kelvin, we are taking the value of R. We are taking the value of R in terms of kilojoule per kg Kelvin, kilojoule per kg Kelvin, and here value of temperature we are taking in terms of Kelvin. So here Kelvin will get cancelled, and we will get the value of W122 in terms of kilojoule per kg. So this is the value of W122. Similarly, we have to calculate the work obtained during the process 3 to 4. Now, how to calculate the work obtained during the process 3 to 4 per kg of air? So same formula, W3 to 4, again as that is a polytropic process. So we have to use the formula as a W3 to 4 is nothing but N upon N minus 1 into R into T3 minus T4. Here value of R we are knowing, value of N we are knowing, value of T3 also we are knowing. Unknown quantity is nothing but T4. How to calculate the value of T4? To calculate the value of T4, again we have to use the equation or process, or we have to see the process 3 to 4. So as process 3 to 4 is a polytropic process, so I can use the formula as a T3 by T4 is equal to T3 by P4 raised to N minus 1 upon N. So here put the value of T3, put the value of P4, and put the value of N. I will get the ratio, that is nothing but T3 by T4. But as I am knowing the value of T3, so I will get the value of T4 as a T3 by 1.45. So here I will get the value of T4 as a 205.5 Kelvin. So put this value of T4 in this equation. Put this value of T4 in this equation. I will get the value of work obtained during process 3 to 4 per kg of air. So that value of W3 to 4 is nothing but 118.2 kilojoule per kg. 118.2 kilojoule per kg. That is nothing but the value of W3 to 4. Again, now as I have calculated the value of W1 to 2, I have calculated the value of W1 to 2, and again I have calculated the value of W3 to 4. Now which value is higher? So here for W1 to 2, as we have to consider this much area, because area under PV diagram will get the work supplied or work obtained. So W1 to 2 is nothing but this much area, this much entire area, and W3 to 4. W3 to 4 means we have to consider the process 3 to 4. We have to consider the process 3 to 4. So from this process up to this much area. So this area is called as a W3 to 4. So which area is larger one? W1 to 2 is larger as compared to W3 to 4. So here, if I want to calculate net work done, if I want to calculate net work done during the process, then that net work done will be calculated by using the formula W is equal to W1 to 2 minus W3 to 4. So here, net work done per kg of air supplied is nothing but W1 to 2 minus W3 to 4, which is nothing but equal to 44.5 kilojoule per kg. Now to calculate the value of COP, here we are knowing the formula. COP is given by equation amount of heat absorbed divided by W net. Out of that W net we have calculated. That means we have to calculate the value of amount of heat absorption. Now during which process heat is being absorbed? During process 4 to 1 heat is being absorbed. And to calculate the amount of heat absorption, which formula we are going to use? So mCp delta T or TDS. But when to use the TDS? If process 4 to 1 is a constant temperature process. But as process 421 is not a constant temperature process, so we have to use the formula as a mCp delta T. But here, as we are not knowing the mass of air circulated, so that's why we will consider per kg of air. That means we are going to use the formula as a Cp into delta T. So which delta T we have to consider? Highest temperature minus lowest temperature during the process 4 to 1. So highest temperature is nothing but T1 and lowest temperature is nothing but T4. So T1 minus T4 instead of delta T. So I will get the value of QA. So by using the same method, calculate the value of QA. So calculate the value of QA. So heat extracted, that heat extraction is also called as a heat absorbed. So heat absorbed from the refrigerating system per kg of air, that will be calculated by using the formula Cp into delta T, whereas delta T is nothing but T1 minus T4. So we are knowing the value of Cp, we are knowing the value of T1, we are knowing the value of T4. So we'll get the value of amount of heat absorbed per kg of air. Here as kilojoule per kg we are getting, that means here this is nothing but amount of heat absorbed per kg of air. Are you getting up to here? Any problem? इथपर्यंत कुणाला काय प्रॉब्लेम आहे का? हॅलो हॅलो, कुणाला प्रॉब्लेम आहे का? पंकज खंबीरे.
नाही, प्रॉब्लेम नाही सर.
Okay, so here we have calculated the value of QA, we have calculated the value of W net. So now next one is nothing but theoretical COP of refrigerating cycle. So theoretical COP of refrigerating cycle is nothing but QA upon W net. So put the value of QA in the numerator, that is nothing but 78. Work done is nothing but 44.5. So here I will get the value of COP of the refrigeration cycle. So this will be called as a theoretical COP of the refrigerating cycle. This will be called as a theoretical COP of the refrigerating cycle. So that is nothing but your answer number 1. इथपर्यंत समजलं का सगळ्यांना? आत्रे, श्रीरंग आत्रे. ओके, इथपर्यंत सगळं समजलं सगळ्यांना?
हा सर.
ओके, आता दुसरी गोष्ट आपल्याला काय फाइंड आउट करायचे? सेकंड थिंग, इफ यू सी द प्रॉब्लेम स्टेटमेंट. But next thing we have to find out, we have to calculate the mass of air circulated per kg. Here if you read this statement, if you read this statement, if load on the refrigerating machine is 10 TR, load on a refrigerating machine is 10 TR. 10 TR is nothing but load, that is nothing but capacity of refrigerating machine. That is nothing but capacity of refrigerating machine. What is the capacity of that refrigerating machine? 10 TR. 10 TR means how much? 10 into 210, because we are knowing the conversion factor of TR into kilojoule per minute. So 10 into 210, that is nothing but kilojoule per minute. म्हणजे ह्याचा अर्थ काय होतोय? 10 into 210 म्हणजे किती झाले? 2100 झाले. 2100 किलोजूल पर मिनिट. त्याचा अर्थ काय होतोय? जे काय आपण रेफ्रिजरेटिंग मशीन यूज करतोय, त्याची कॅपॅसिटी किती आहे? 2100 किलोजूल पर मिनिट आहे. किलोजूल पर मिनिट म्हणजे काय? एका मिनिटाला जे काय आपण रेफ्रिजरेटिंग मशीन यूज करतोय ती किती अमाउंट ऑफ हीट ऍब्सॉर्ब करू शकते? 2100 किलोजूल एवढी अमाउंट ऑफ हीट ऍब्सॉर्ब करू शकते. So here if you see the problem statement, if the load on a refrigerating machine is 10 TR, that means they have given the capacity of refrigerating machine which is nothing but 10 TR, which is nothing but equal to 2100 kilojoule per minute. So we have to find out amount of air circulated per minute, that is nothing but mass flow rate of the refrigerant. because here air is used as a refrigerant in case of Bell-Coleman cycle as well as reverse Carnot cycle. So we have to calculate the mass flow rate, but when through the system, assuming that actual COP is 50% of the theoretical COP. When actual COP is 50% of the theoretical COP. Now here, as we have calculated the theoretical COP, what is the value of theoretical COP? So 1.75. 1.75 is nothing but the value of theoretical COP. But what we are knowing, actual COP is nothing but. So to calculate the mass flow rate, as we are knowing that actual COP is nothing but 50% of the theoretical COP. Actual COP is nothing but 50% of theoretical COP. So actual COP will be equal to sorry for 1 minute. So as actual COP is 50% of theoretical COP, that means actual heat extraction or actual heat absorbed by that refrigerator will be equal to 50% of amount of heat absorbed. So here, what is the amount of heat extracted? Actual amount of, theoretical heat absorption. So here, whatever 78, here, whatever this value we have calculated, this is nothing but the theoretical amount of heat absorption. This is nothing but theoretical heat absorption during the process 4-1. But as we are knowing that actual COP is 50% of theoretical COP. Actual COP is 50% of theoretical COP. That means actual amount of heat absorption. That means actual amount of heat absorption during the refrigeration process will be 50% of theoretical amount of heat absorption. Are you getting this statement? If in the problem, if they will mention that actual COP is 50% of theoretical COP, that means they want to say that whatever actual amount of heat absorption we are absorbing in the refrigerating system, that is nothing but 50% of theoretical heat absorption. So what is the theoretical heat absorption capacity? 78 kilojoule per kg is nothing but theoretical heat absorption capacity. So actual heat absorption capacity per kg of system or per kg of air will be equal to 50% of 78, that is nothing but 39 kilojoule per kg. Now as we have calculated 39 kilojoule per kg, here 39 kilojoule per kg is nothing but actual amount of heat absorbed. Actual amount of heat absorbed during the process 4-1. So here as capacity of refrigerating system is nothing but 10 TR. So 10 TR means how much amount of heat that refrigerating system can absorb per minute? 21,000 kilojoule amount of heat that refrigerating system is able to absorb per minute. But here this is the capacity of refrigerating system and this is nothing but the actual amount of heat absorption per kg of the air. Now here if I want to calculate mass of air circulated, so if you are not written, then write down the formula for mass of air circulated. All of you please write down the formula in your notebook. Mass of air circulated is equal to mass of air circulated is equal to mass of air circulated is equal to capacity of system, capacity of refrigerating system in kilojoule per minute divided by heat absorbed heat absorbed in kilojoule per kg. Kilojoule per kg. Have you written this formula? By using this formula, always we are calculating the mass of air circulated to the system. So here, 1 minute. So here, as you are knowing the capacity of refrigerating system in terms of kilojoule. Okay. As here, you are knowing the capacity of refrigerating system in terms of kilojoule per minute. Kilojoule per minute. And you are knowing the amount of heat absorbed here. QA. In the last slide, you have calculated. Here, amount of heat absorbed in terms of kilojoule per kg. Kilojoule per kg. So our formula to calculate the value of mass of air circulated per mass of air circulated per minute is nothing but capacity in kilojoule per minute divided by heat absorbed in kilojoule per kg. So here, per kilojoule will get cancelled. Kilojoule will get cancelled. Kilojoule will get cancelled, and whatever our answer will be there, that will be in terms of kg per minute. So here, put the value of capacity, that is nothing but 2100. Put the value of heat absorption, that is nothing but 39. So you will get the value of mass of air circulated to the system per minute. So this is the solution of your problem. Are you getting the solution? Is there any another problem? Is there any problem? सगळ्यांना समजलंय का? काहीतरी सांगा. कुठे अडचण असेल तर विचारा, तिथून रिपीट करतो असल्यास. हॅलो, सगळ्यांना समजलंय? In the chat box you can give the reply. How many of you understood the problem? If you understood the problem, write in the chat box, that is yes. And if you haven't understood the problem, you can write down in the problem not understood. The remaining student, write in chat box. What about remaining student? Okay. So now we'll take one more problem. That will be the last problem. So last problem based on Bell-Coleman cycle. So we'll read the problem. Yogesh Raut, read the problem loudly.
A dense air machine operates on a reverse Breton cycle and is required for a capacity of 10 TR. The color the color pressure is 4.2 bar and refrigerator
Cooler
pressure.
pressure.
Cooler pressure is 4.2 bar and the refrigerator pressure 1.4 bar. The air is cooled in cooler at temperature 50 degree Celsius and temperature of air at inlet to compressor is minus 20 degree Celsius. Determine the ideal cycle.
Determined for ideal cycle. First one COP. Second one mass of air circulated per minute. Third one theoretical piston displacement of a compressor. Fourth one theoretical piston displacement of the expander. And last one net power per ton of refrigeration. Show the cycle on PV and TS plants. That means you have to also draw the PV and TS diagram. So here dense air refrigeration system means the closed Bell-Coleman cycle is called as a dense refrigeration system, and open type of cycle is called as a open reverse Brayton cycle or Bell-Coleman cycle. So here we'll go it little bit fastly because as this is last problem, so you might have understood the problem. So here first of all they have given the capacity. So what is the capacity in the given data? First of all they have given the capacity. Capacity means amount of heat absorption that system can obtain or that system can have. That is nothing but 10 TR. Here two pressure they have mentioned. Cooler pressure 4.2 bar and refrigerator pressure 1.4 bar. Cooler pressure means higher pressure. So that is nothing but the value of P2 is equal to P3, which is equal to 4.2 bar. Refrigerator pressure means lower pressure, that is nothing but P1 is equal to P4, which is nothing but 1.4 bar. The air is cooled in the cooler at a temperature of 50 degrees centigrade. What is the meaning of this? Which value they have mentioned? Air is cooled in the cooler at a temperature of 50 degrees centigrade. पहिल्यांदा सिस्टीम कोणती असते? कॉम्प्रेसरची सिस्टीम असते, त्यानंतर कूलरची, त्यानंतर एक्सपांडरची आणि त्यानंतर रेफ्रिजरेटरची असते. एअर इज कूल्ड इन द कूलर ॲट अ टेम्परेचर ऑफ 50 डिग्री सेंटीग्रेड मीन्स दे हॅव मेन्शन द व्हॅल्यू ऑफ विच व्हॅल्यू दे हॅव मेन्शन? कॅन एनीबडी टेल मी? कोणती व्हॅल्यू 50 डिग्री सेंटीग्रेड म्हणजे?
T1.
T1. कॉम्प्रेसरचं इनलेट आपण नेहमी 1 घेत असतो. हे काय? कूलरचं आउटलेट आहे. कूलरचं आउटलेट आहे. कॉम्प्रेसरचं इनलेट 1 झालं, कॉम्प्रेसरचं आउटलेट म्हणजेच कूलरचं इनलेट 2 झाला. कूलरचं आउटलेट म्हणजेच एक्सपांडरचं इनलेट पॉईंट नंबर 3 झाला. आणि एक्सपांडरचं आउटलेट म्हणजेच काय झालं? आपला इव्हापरेटर, त्याला आपण रेफ्रिजरेटर म्हणतो, त्याचा इनलेट जो आहे तो पॉईंट नंबर 4 झाला. आणि रेफ्रिजरेटर किंवा इव्हापरेटरचं आउटलेट म्हणजेच कॉम्प्रेसरचं इनलेट काय झालं? 1 झालं. आता कोणतं असलं टेम्परेचर असणार आहे? T1, T2, T3, T4. हे जर समजलं नाही तर कम्प्लीट प्रॉब्लेम चुकणार आहे तुमचा. विच इज दिस व्हॅल्यू 50 डिग्री सेंटीग्रेड. आउटलेट ऑफ कूलर दॅट इज नथिंग बट इनलेट ऑफ एक्सपांडर. एक्सपान्शनची प्रोसेस कोणती असते? 3 to 4. कूलरची प्रोसेस कोणती असते? 2 to 3. आउटलेट ऑफ कूलर म्हणजे कोणतं झालं? T3 झालं. सो दिस इज द व्हॅल्यू ऑफ T3, 50 डिग्री सेंटीग्रेड. And temperature of air at the inlet of compressor is minus 20 degree centigrade. That means which value they have mentioned? 20 degree centigrade. Minus 20 degree centigrade. T1. T1. So here that is nothing but the value of T1. So determined for ideal cycle COP. Determined for ideal cycle. काय काय फाइंड आउट करायचं आपल्याला? पहिली गोष्ट म्हणजे काय फाइंड आउट करायचे? COP कॅल्क्युलेट करायचे. Second one, mass of air circulated per minute, that is nothing but m dot a. Theoretical piston displacement of a compressor. Wait. Wait for 1 minute. Theoretical piston displacement of compressor means which value we have to find out? Can anybody tell me? Theoretical piston displacement of compressor. That means we have to calculate the value of P1 also. Here, if you see, first thing we have to calculate the value of COP. Second thing, we have to calculate mass of air circulated. That is nothing but ma dot. Third thing, we have to calculate theoretical piston displacement of compressor. जर माहित नसेल तर नोटबुक मध्ये लिहा. Theoretical piston displacement of compressor म्हणजे कोणती व्हॅल्यू फाइंड आउट करायची असते तुम्हाला? P1. आणि theoretical piston displacement of expander म्हणजे कोणती व्हॅल्यू फाइंड आउट करायची असते तुम्हाला? P4 कॅल्क्युलेट करायची असते. माहित नसेल तर लिहून घ्या. ऑल ऑफ यू प्लीज. Theoretical piston displacement of compressor is nothing but value of P1. Theoretical piston displacement of expander is nothing but value of P4. लिहिलं का? And last one, we have to calculate net power per ton of refrigeration. Last thing, we have to calculate power per ton of refrigeration. So again they have mentioned that show the cycle on PV and TS plane. So we are knowing the PV and TS diagram for Bell-Coleman cycle. So those are the PV and TS diagram for Bell-Coleman cycle. So according to the input or according to the given data, write down these values. So 4.2 bar, which is nothing but T2 is equal to T3. 1.4, T4 is equal to T1. Value of T3 is nothing but 323. Value of T1 is nothing but 253. Now first thing, what we have to calculate? We have to calculate the value of COP. Now to calculate the value of COP, here you can use here whether they have mentioned that whether isentropic those processes, compression and expansion processes are following this and this law. असं काय मेन्शन केलेलं आहे का त्यांनी? केलंय का? कॉम्प्रेशन आणि एक्सपान्शन आयसेंट्रॉपिक आहे पॉलिट्रॉपिक आहे काय सांगितलंय का त्यांनी? लवकर सांगा बघू.
नाही
नाही सांगितलं. म्हणजे वी हॅव टू अज्युम दॅट कॉम्प्रेशन अँड एक्सपान्शन प्रोसेसेस आर आयसेंट्रॉपिक. ज्यावेळेस दिलेलं नसतं त्यावेळेस काय अज्युम करायचं आपल्याला? दोज आर आयसेंट्रॉपिक प्रोसेस. दॅट मीन्स दोज आर फॉलोइंग द लॉ PV raised to 1.4 is equal to constant. त्या केसमध्ये आपल्याला COP जर कॅल्क्युलेट करायचं असेल, बोथ प्रोसेसेस आर आयसेंट्रॉपिक प्रोसेसेस, त्यावेळेस आपण कोणता फॉर्म्युला यूज करत असतो? आयदर फॉर्म्युला नंबर 1 और फॉर्म्युला नंबर 3. फॉर्म्युला नंबर कोणता 1 आहे? 1 अपॉन RP raised to gamma minus 1 अपॉन gamma minus 1. किंवा हा फॉर्म्युला नंबर 2 कोणता आहे? T1 minus T4 डिवाइडेड बाय T2 minus T3 minus T1 minus T4. फॉर्म्युला नंबर 1 किंवा फॉर्म्युला नंबर 3 दोन्हीपैकी कोणताही फॉर्म्युला यूज केला तरी तुम्हाला काय मिळेल? COP ची व्हॅल्यू मिळेल. समजतंय? येस और नो? So here we are going to use the formula number 3. Formula number 3 is nothing but T1 minus T4 divided by T2 minus T3 minus T1 minus T4. त्यापैकी आपल्याला काय माहित आहे? T1 ची व्हॅल्यू माहित आहे आपल्याला, T3 ची व्हॅल्यू माहित आहे, पण T4 आणि T2 या दोन व्हॅल्यू माहित आहेत का? T2 आणि T4 माहित आहेत का? इथं T1 आणि T3 दिलेलं आहे. So T2 and T4 are unknown term. So to calculate the value of T2 and T4, we are going to use the equation 1 to 2. So from equation 1 to 2, we'll get that T2 by T1 is equal to P2 by P1 raised to gamma minus 1 upon gamma. त्या ठिकाणी काय अज्युम केलेलं आहे आपण? Let us assume compression and expansion are isentropic. So gamma value will be 1.4. So here value of T1 is known to you, value of P2, value of P1, value of gamma is known to you. You are able to calculate the value of T2. So value of T2 is nothing but 346 Kelvin. Similarly, to calculate the value of T4, you are going to use the formula T3 by T4 is equal to P3 by P4 raised to gamma minus 1 upon gamma. त्या ठिकाणी पण काय माहित आहे तुम्हाला? P3 माहित आहे, P4 माहित आहे, gamma ची व्हॅल्यू माहित आहे आणि T3 ची पण व्हॅल्यू माहित आहे. So T4 will be easily calculated. So this will be the value of T4. Sorry, this will be the value of T4. आता T2 काढला, T4 काढला, T4 काढल्यानंतर COP च्या ह्या फॉर्म्युल्यामध्ये पुटअप करा, तुम्हाला काय मिळेल? COP ची व्हॅल्यू मिळून जाईल. So this will be the value of COP. Are you getting everyone? Yes or no? समजलं इथपर्यंत? Yes or no? So now second point is we have to calculate the mass of air circulated per minute. So what is the formula we are knowing? How to calculate the mass of air circulated per minute? So mass of air circulated per minute is nothing but capacity. Capacity, in which term we are mentioning capacity? In terms of kilojoule per minute. Kilojoule per minute divided by दुसरं काय पाहिजे असतं आपल्याला? Capacity divided by amount of heat absorbed QA. Amount of heat absorbed. पण हे heat absorption कशामध्ये पाहिजे असतं आपल्याला? किलोजूल पर केजी मध्ये पाहिजे असतं. बरोबर आहे? हा फॉर्म्युला आहे. To calculate the mass of air circulated, we are knowing this formula. So first of all, we are knowing the capacity. What is the capacity of machine? 10 TR. 10 TR means या ठिकाणी पण मेन्शन केलेलं आहे. Capacity of machine is 10 TR. मेन्शन केलेलं आहे ना, सुरुवातीलाच मेन्शन केलेलं आहे. So here 10 TR means amount of heat absorption in terms or capacity in terms of kilojoule per minute किती येणार आहे, 2100 किलोजूल पर मिनिट. परत दुसरं काय कॅल्क्युलेट करावं लागणार आहे, QA कॅल्क्युलेट करावं लागणार आहे. आता QA म्हणजे काय, अमाउंट ऑफ हीट एक्सट्रॅक्टेड और अमाउंट ऑफ हीट एब्सॉर्ब फ्रॉम द रेफ्रिजरेटिंग सिस्टम पर kg of air. So during which process heat is being absorbed? During process 4 to 1. During process 4 to 1 heat is being absorbed and per kg. So amount of heat absorbed per kg will be given by equation Cp into T1 minus T4. Cp into T1 minus T4. Put the value of Cp here. Whether value of Cp is mentioned in the problem, they are not mentioned in the problem. So whenever they are not going to mention in the problem, there we have to take the value of Cp as a 1 kilojoule per kg Kelvin. And if they are going to mention, they will, or corrected value is for Cp for air is nothing but 1.005. So both the value you can consider, there will not be much more difference, either 1 or 1.005. So Cp value you are knowing, T1 value, T4 value. Here you will get the value of amount of heat absorbed, that is nothing but QA, and this value will be in terms of kilojoule per kg. So value of capacity you have calculated in terms of kilojoule per minute. Now as you have calculated the capacity in kilojoule per minute and QA in terms of kilojoule per kg, so here value of mass of air circulated is nothing but capacity in kilojoule per minute divided by amount of heat absorption in kilojoule per kg. So put the value of capacity, that is nothing but 2100. Put the value of QA, that is nothing but 17. So you will get the value of mass of air circulated. This value of mass of air circulated will be in terms of kg per minute. इथपर्यंत समजलं सगळ्यांना? Are you getting? Yes or no? काहीतरी सांगा. इथपर्यंत समजलं? Okay. Now third thing, you have to calculate the theoretical piston displacement of compressor. Theoretical piston displacement of compressor means you have to calculate the value of P1. You have to calculate the value of P1. So to calculate the value of P1, you have to use the ideal gas equation. That is nothing but P1 P1 is equal to M1 R1 T1, or P1 P1 is equal to MR T1. So here, as you are knowing that P1 P1 is nothing but MR T1, whereas P1 is nothing but theoretical piston displacement of compressor per minute. So here, from that equation P1 P1 is equal to MR T1, we will get the value of P1 as a MA RA T1 divided by P1. T1 divided by P1. Now here, if you see, we require the value of P1 in terms of per minute. That is nothing but P1. We require the value of P1, that is nothing but in terms of meter cube per minute. Meter cube per minute. So while considering the value of MA, we have to consider the value of MA in terms of kg per minute. We require the value of MA in terms of kg per minute. Here I am unable to write properly by using this pointer. Value of RA always we have to consider as a 287, because that value will be in terms of joule per kg Kelvin. Joule per kg Kelvin. And whatever value of T1 we are going to consider, that value of T1 we have to consider in terms of Kelvin. And whatever value of P1 we are considering, that again value of P1 always we are required to calculate in terms of Newton per meter square, not in terms of bar. So here we are knowing the value of P1 in terms of bar. What is the value of P1? 1.4 bar. Convert it in terms of Newton per meter square. So that will be 1.4 Newton, 1.4 into 10 raised to 5 Newton per meter square. 5 we are considering this in terms of joule, because here if you get time, so here only you can mention that MA is in terms of kg per minute, RA is in terms of joule per kg Kelvin, Ka or T1 is in terms of Kelvin, T1 is in terms of Newton per meter square. So automatically you will get the value of volume in terms of meter cube per minute. So put all those values So value of MA we are knowing 123.5 kg per minute. Value of RA in terms of joule per kg Kelvin is nothing but 287. Value of T1 in terms of Kelvin we are knowing, and value of P1 in terms of Newton per meter square. So automatically I'll get the value of P1. इथपर्यंत समजलं सगळ्यांना? लास्टचे 2 ते 3 मिनिट राहिले. इथपर्यंत समजलं का? Yes or no?
Yes, sir.
Okay. Similarly, we have to calculate the value of P4. That is nothing but theoretical piston displacement of expander. We have to calculate the value of P4. So to calculate the value of P4, how we have to calculate the value of P4? P4 कसं calculate करणार आहे आपण? कोण सांगू शकेल? त्या ठिकाणी पण तुम्ही P4 कॅल्क्युलेट करण्यासाठी P4 इज इक्वल टू MAR P4 हा फॉर्म्युला यूज करू शकता. P4 V4 इज इक्वल टू MAR P4 हा फॉर्म्युला यूज करू शकता. P4 ची व्हॅल्यू माहित आहे, R ची व्हॅल्यू माहित आहे, MA ची व्हॅल्यू माहित आहे, P4 ची व्हॅल्यू माहित आहे. त्यावरून P4 पण कॅल्क्युलेट करू शकता. किंवा दुसरा फॉर्म्युला काय, तुम्हाला चार्ल्स लॉ माहित आहे. आपली प्रोसेस 3 to 4 कशी आहे, सॉरी प्रोसेस 4 to 1 कसे, that is nothing but constant pressure heat absorption process. So for constant pressure heat absorption process, constant pressure म्हणजे कोणता झाला, चार्ल्स लॉ झाला. आणि चार्ल्स लॉ नुसार आपल्याला काय माहित आहे, चलो व्हॉल्यूम इज डायरेक्टली प्रोपोर्शनल टू टेम्परेचर. बॉयल्स लॉ, चार्ल्स लॉ, गेलस लॉ माहित आहे तुम्हाला. त्यापैकी चार्ल्स लॉ कसे, कधी कॉन्स्टंट प्रेशर असेल तर दॅट इज नथिंग बट P इज डायरेक्टली प्रोपोर्शनल टू T. So as P is directly proportional to T, so we are knowing that P4 divided by T4 is nothing but equal to P1 divided by T1. P is directly proportional to T, that is called as a Charles law. So here P4 is equal to constant into, constant will be considered as K into T4, and similarly P1 is equal to constant into T1. तर कॉन्स्टंटची व्हॅल्यू काय येणार आहे, P4 डिवाइडेड बाय T4. कॉन्स्टंटची व्हॅल्यू काय येणार आहे, P1 डिवाइडेड बाय T1. कॉन्स्टंट काय असणार आहे, सेम असणार आहे. त्यामुळे काय घेताय तुम्ही, P4 डिवाइडेड बाय T4 इज इक्वल टू P1 डिवाइडेड बाय T1. त्यापैकी P1 ची व्हॅल्यू माहित आहे, T1 ची व्हॅल्यू माहित आहे, T4 ची व्हॅल्यू माहित आहे. पुट ऑल दोज व्हॅल्यू, यू विल ऑटोमॅटिकली गेट द व्हॅल्यू ऑफ P4. सो व्हॅल्यू ऑफ P4 इज नथिंग बट 60 मीटर क्यूब पर मिनिट असणार आहे, फक्त मीटर क्यूब नाही, because you are putting the value of P1 in terms of meter cube per minute. So this will be the value of P4. समजते? इथपर्यंत समजलं का? Yes or no?
Yes, sir.
Okay. Now last thing, we have to calculate net power per ton of refrigeration. तर नेट पॉवर म्हणजे काय, आपल्याला अगोदर नेट वर्क डन कॅल्क्युलेट करावं लागेल. तर नेट वर्क डन कॅल्क्युलेट करण्यासाठी आपल्याला काय माहित आहे, अमाउंट ऑफ हीट ॲब्झॉर्प्शन माहित आहे. तो नेट वर्क डन इज नथिंग बट अमाउंट ऑफ हीट ॲब्झॉर्ब इंटू, सॉरी मास ऑफ एअर इंटू हीट रिजेक्टेड मायनस हीट एक्सट्रॅक्टेड, दॅट इज नथिंग बट MCP. इथं लक्ष द्या. आपल्याला काय कॅल्क्युलेट करायचं आहे, नेट वर्क डन कॅल्क्युलेट करायचं आहे. नेट वर्क डन कसं कॅल्क्युलेट करू शकतो आपण, बेस्ड ऑन हीट ॲब्झॉर्प्शन आणि हीट रिजेक्शन. त्यावरून कसं कॅल्क्युलेट करू शकतो, हीट रिजेक्टेड मायनस हीट ॲब्झॉर्प्शन, हीट रिजेक्टेड मायनस हीट ॲब्झॉर्प्शन. त्या एका मेथडनं कॅल्क्युलेट करू शकतो. किंवा दुसरी मेथड कोणते, नेट वर्क डनची W122 कॅल्क्युलेट करणं, W122 कॅल्क्युलेट करणं मायनस W324 करणं. दोन्ही मेथडनं तुम्हाला काय मिळते, नेट वर्क डन मिळते. पण ह्या ठिकाणी आता तुम्ही T2, T3 आणि T4 कॅल्क्युलेट केलेले, त्यामुळं ही मेथड यूज करतो आपण. कोणती मेथड यूज करा, काही प्रॉब्लेम नाही. दोन्ही मेथडनं तुम्हाला काय मिळणार आहे, W नेट मिळणार आहे. आता W नेट कॅल्क्युलेट करायचं असेल तर QR कसा कॅल्क्युलेट करतो आपण, MCP डेल्टा T. MCP डेल्टा T म्हणजे काय झाला, M इंटू CP इंटू T2 मायनस T3. आणि QA कसा कॅल्क्युलेट करतो आपण, mcp delta t. mcp delta t म्हणजे हा टेम्परेचर डिफरन्स घेणार. mcp t1 मायनस t4. पण m इंटू cp काय कॉन्स्टंट टर्म आहे, त्यामुळे आपण काय करतो ब्रॅकेटच्या बाहेर घेतो, बाकीच्या टर्म ब्रॅकेट मध्ये ठेवतो. समजते? सो पुट ऑल दोज व्हॅल्यू. I will get the net work done. This is nothing but net work done in terms of kilojoule per minute. पण आपल्याला काय विचारलेलं आहे, नेट पॉवर विचारलेलं. पॉवर म्हणजे काय असतं, पॉवर कशामध्ये ऑलवेज मेन्शन करतो आपण, किलोवॅट मध्ये मेन्शन करतो, बरोबर आहे. आणि किलोवॅट म्हणजे काय असतं, किलोजूल पर सेकंद असतं. पण हे कशामध्ये, किलोजूल पर मिनिट मध्ये. जर मी ह्याचं जर किलोजूल पर सेकंद मध्ये कन्वर्जन करायचं असेल तर मला काय करावं लागणार आहे, डिवाइडेड बाय 60 करावं लागणार. सो डिवाइड दिस आन्सर बाय 60. So net power will be equal to 12.35 kilowatt. हे काय झालं, नेट पॉवर झाली पर टन ऑफ रेफ्रिजरेशन. पर टन ऑफ रेफ्रिजरेशन म्हणजे काय, किती कॅपॅसिटी, 10 कॅपॅसिटी, 10 TR कॅपॅसिटी, म्हणजे पर टन ऑफ रेफ्रिजरेशन काय येणार आहे, डिवाइडेड बाय 10. 12.35 divided by 10. So this value will be in terms of kilowatt per TR. That is nothing but net power per ton of refrigeration. Are you getting? So this was the solution of the problem. Have you understood the problem? Hello? Have you understood the problem, everyone? Yes or no? Yes or no? Hello?
Yes, sir.
Okay. So here we are going to end our lecture. Wait for 1 minute. Let me take the attendance. After that, you can exit from the meeting. Okay. I have taken the attendance. So thank you for attending the lecture. Thank you very much. You can exit from the meeting. Thank you.